These are the solutions to question number 3 for the 2014 linear algebra examination. Question 3a, we want to determine which of these subsets are subspaces. And for part B, we want to determine the coordinates of a vector with respect to this basis. And then for part C, we want to show that these three vectors are linearly independent. So for part A, we consider the subset W1 first of all. And whenever you have expressions like this involving numbers, that gives you a clue it's not a vector space, a subspace. So in this case, it's not a subspace. We want to find one counterexample. So for example, the vector 1, 1, 2, 0 belongs to W1. And that's because C is equal to A plus 1 and D is equal to A minus 1. So this vector does belong to W1. However, if we multiply this vector by the scalar minus 1, then we get this vector, minus 1, minus 1. Oh, that should be the minus 2 there, and then 0. But then you can see that this no longer belongs to W1. So for example, this element here, C, should equal A plus 1. But A plus 1 would equal 0. This element should be 0, but you can see it should be minus 2. So this vector does not belong to W1, so W1 is not a subspace. W2 is non-empty, so here's W2. It's C is equal to A plus B, D is equal to A minus B. So it's not empty because, as you can see here, C is equal to A plus B, so that's okay, and D is equal to A minus B. So this vector is in W2. Now to prove it's a subspace, we take two general vectors. So here U is the vector of this form and V is the vector of this form. And now you can see that these are two general vectors which are in W2. So C is equal to A plus B and D is equal to A minus B. And here you can see that this vector is C plus D and this vector is C minus D. So these belong to W2. Alpha is a real number. Now if we consider the vector alpha A plus V, then using the algebra of vectors, then we can write this vector as a single vector of this form. And then you can see that the third element here is equal to the first plus the second, and the fourth element is equal to the first, take away the second. So this general vector also belongs to W2. So therefore, W2 is a non-empty subspace of V, and that should be V4 over R. Okay, for question number 3, part B, we want to write this vector as a multiple of these three vectors which form the basis. And these are just simultaneous equations. So you can see that A minus C is equal to 3. 2A plus 5B plus C is equal to 0. And 7B plus 3C will give you minus 1. And I'll leave you to check that on your own. But you should easily be able to show that A is minus 19 over 6. B is 5 over 2. And C is minus 37 over 6. So these are just solving simultaneous equations. And for part C, to show that these three vectors are linearly independent, we simply find this 3 by 3 determinant, and we get the answer 4, which is non-zero. So therefore, these three vectors are linearly independent. And that concludes the solutions to question number 3.